In this video, we are going to address the very important question of how do we specify a covariance structure when we are carrying out a linear model analysis. Now, the sad fact is that with respect to this particular aspect, specification of covariance structures, all the softwares available in the market are as different from one another as possible. So R does it in one way, SPSS does it in a completely different way, and SAS does it in yet another different way. So if you learn one, expect to spend at least 1 week of frantic exploration in order to figure out how to use another software for this purpose. And also R is particularly weak in this aspect, but we are going to use R. So let us see how we can do it using R. Now, whatever I am going to discuss here is not particularly complete, that it is difficult to make a complete presentation of what R can do, though R cannot do much. And I would suggest that if you are interested in learning about further details, that you go through this book. It is by Pinheiro and Bates, and the book is called Mixed Effects Models in S and S+. However, more or less the same syntax works for R. So with some minor differences that I'm going to point out, the thing will work. Okay, so let's dive into our thing. So here is my sample code that I'll be using. Now the first thing that you notice is that I have to use a new library called NLME. NLME stands for Nonlinear Mixed Effect. Okay, so then what I'm planning to do is that I will create my own data set for this example so that you can play around with it. So if you look up the help of R, you will see lots of ready-made data sets and on which they are using this. They're real-life data sets, but then you cannot really play with those things because you cannot quickly modify those data sets to suit your need in order to explore. So what I have done is, I have created my own data set that is sort of custom made to illustrate various features. So this is basically that variety versus fertilizer thing. So what I am doing is, first variety numbers, I call them phenome, and I'm going to make it into a factor, so I've just called it a factor. So it's not very important that I call it a factor. I might as well remove this. So I am saying rep 1 to 4, which means 1, 1, 1 4 times, then rep 2 4 times, and 3 4 times. So 4 1s followed by 4 2s followed by 4 3s and C together. So that's a long vector. So let me just start executing the stuff so that I can show you the effect. So let's see what our vnom is. Vnom is 4 1s followed by 4 2s followed by 4 3s. Then I am creating something called fnom, which is called the fertilizers encoded as numbers. So what it is doing is it taking 2 1s, then 2 2s, and repeating the entire thing 3 times. So here is my fnom. Sorry, I just typed it here. I am supposed to type it here. So it is 2 1s followed by 2 2s, and this entire pattern repeated 3 times. Now I will create my model without interaction. So I create some arbitrary alpha vector, alpha 1 2 3, and arbitrary beta vector, beta 3 3. So that effect is not really present. And I create a mu. Then I create my yield in this way. So I keep mu plus alpha I plus beta j plus I just added some random number. The 12 comes from the fact that I have got 12 such things. So I have got 3 varieties, I have got 2 fertilizers, and number of replication per fertilizer variety combination is 2. So that gives me 12 different plots, and I have simulated their yield. So if I take a look at my yields, then I get these 12 numbers. Okay, now I want to associate names with them, so I give V name. I just give some varieties of paddies. So I call them Joya, Taichung and IR8, and F name. There are two types of fertilizers, none versus say compost. And then I create my data by packing everything, data frame, yield, vname of vnum, so that is variety and fertilizer. So let's take a look at my DAT. It is just like this. So I have got yield, variety, fertilizer, and yields are these. Taichung, IR8, none, compost. So under Jaya none combination, I have got two plots. So I have this data set. Now what I want to do is that I want to make it unbalanced, because that will illustrate certain feature. So I will make it unbalanced. So let me get back here. So I will just remove the first row of the data set by writing dat equal to dat of -1. So I'm removing the first row, which gives me this data set. The same thing as before, but now it starts from 2. So you see that Jaya none pattern repeats only once and the other things repeat twice.